Hello everybody, this video is going to cover our 7.3 notes, which is going to cover cones. So in the last two videos we covered prisms and we covered cylinders. Both prisms and cylinders have two bases, and now we are going to start on the 3D shapes that have a singular base, cones. So a cone has a circular base and a vertex that is not in the same plane as the base. So what they're talking about here is this is your base. I did not do that very well. This is your base, okay? And then you have a vertex, which is not in the same plane as the base. In a right circular cone, the altitude is perpendicular to the base at the center of the circle, which is what you see over here in this picture. Okay, I want to say that all of the cones that we do are going to be right circular cones, but I could just have lied to you, but I want to say that pretty much every cone we talk about in here is going to be a right circular cone. Okay, now, one thing that I do want to talk about here are the different parts of our cone. So obviously we have our base, we have our radius down here, we have our height, which is here, and then we have this new thing that is in the shape of this funny looking L, and that is known as our slant height. So whenever you have a cone and whenever you have a pyramid, which we'll talk about tomorrow, you're going to have two different heights. You've got your vertical height, and then you've got your slant height. And you will see your vertical height sometimes, and then you will see your slant height sometimes. So it's really important for us to know the difference between our height and our slant height. All right, formulas for cones. So cone formula is not the same as cylinder/prism formulas. They are a little bit different. So our lateral area is going to be P times L divided by 2. P is the perimeter of our base. So again, because it's our base and our base is a cone and it's a circle, it's going to be 2 pi r. And then L is going to be our slant height. I'm making a video. You're going to have to wait. Sure, but you're not going to be able to talk while we're in here, okay? That's fine. Sorry, I got distracted by my child. Okay, now total surface area is going to be like all of the other areas that we've talked about, but in the last two videos we've had in prisms and cylinders, because both of those shapes have two bases, we would have to add our two bases to the lateral area. In a cone, we only have one base, so we're still going to do lateral area, and then we're going to add the one base that we have instead of two bases because cones don't have two bases. So this will be P times L divided by 2 plus 1B, all right? And then big B obviously is the area of the base, and again, your base is a circle, so this will be pi r squared. And then volume is going to be big B times H, but now we're dividing that by 3 because it's volume, all right? And there you go. So just like with everything else that we've done, I want us to write our P, our H, and our B, but now this time we're going to add in our slant height, okay? So looking at this image here, I do not know what my radius is. I'm missing my radius, but because I have a right triangle over here, I can actually just do the Pythagorean theorem to find my radius. So we are going to have to do 12 squared plus r squared equals 13 squared. So 13 squared minus 12 squared gets me 25. So r squared equals 25, which means that my radius is 5. All right, P is the perimeter of our base. Our base is a circle, so it's going to be circumference, which is 2 pi r. So that's going to be 10 pi. The height, remember, is going to be our vertical height, which in this case is 12. Big B is area of our base, which is pi radius squared. So this will be 25 pi. And then our slant height is obviously our slant height, which is going to be 13. Okay, so there's our P, H, B, and L. And then I'm just going to plug these things in. Lateral area is P times L divided by 2. So our perimeter is 10 pi times our slant height divided by 2. So 10 times 13 divided by 2. This will be 65 pi meters squared. Sorry if you hear weird noises in the background. My child's in here. Total area is our lateral area plus 1B. So this will be 65 pi plus big B is 25 pi. So 65 plus 25 equals 90. So this will be 90 pi meters squared. And then volume is big B times H. And now I'm dividing that by 3. So big B is 25 pi. H is 12 divided by 3. So 25 times 12 divided by 3 will give me 100 pi meters cubed. And there we go. Example 2, the lateral area for a cone is 30 pi square meters. Find the radius and the volume. So I'm going to need my radius. I'm missing my height. I'm missing all of these things. So lateral area, this is a backwards problem. We know that lateral area is going to be P times L divided by 2, but we always have to be more precise than that. P is the perimeter of our base, which is 2 pi r, times slant height divided by 2. Now I get to plug in what I know. So lateral area is 30 pi. That's going to equal 2 pi radius times my slant height divided by 2. So this will be 30 pi equals 12 divided by 2 is 6 pi r. Those pi's cancel. Divide both sides by 6. And I get that my radius is 5. So now that I know what my radius is, I need to find the volume. And volume is going to require me to have the height, the vertical height of my cone. So I'm going to go ahead and actually do 5 squared plus h squared equals 6 squared. So 6 squared minus 5 squared is 11. Ew.
11?
Shh, buddy. I'm square rooting both sides, so h is going to equal the square root of 11. Okay. So now, to find the volume, volume is big B times h divided by 3. So I know that big B is the area of the base, which will be 25 pi. And then height, we just said, was the square root of 11. So the volume is going to equal big B times h divided by 3. This is going to be disgusting. All right, so the volume will be 25 pi square root of 11 over 3 meters cubed. Is that disgusting? Yes. Is that the volume? Also yes. All right, so there's example 2. Example 3 says the volume of a cone is 125 pi cubic meters. Find the radius of the cone. So again, I am looking for the radius. I was given volume. Volume is big B times h divided by 3. Got to be more precise than that. This will be pi radius squared times my height, which I have is 15, divided by 3. I should have been, well, okay. I got ahead of myself. Hold on. H divided by 3. Okay. Please stop.
I want to sit next to you.
Okay, so this is 125 pi equals pi. I don't know my radius. I know my height divided by 3. All right, we've got 125 pi equals, this will simplify to 5 pi, radius squared. My pi's cancel. I can go ahead and divide both sides by 5. I'm pretty sure that's 25. It is 25. So my radius squared equals 25. So my radius should equal 5. Radius will be 5 meters. Lots of backwards problems here, which is okay. All right, ooh, last example, so nice. Example 4, a cylindrical water tank has a radius of 3.4 feet and a height of 8.6 feet. The water tank is filled to the top. The water can be pumped out at a rate of 36 cubic feet per minute. Determine to the nearest minute how long it will take to empty the tank. Okay, careful. This says a cylindrical, not a conical. Okay, so we have a cylindrical water tank. It has a radius of 3.4 feet and a height of 8.6 feet. Now, because it's talking about water, that's going to be volume. So as a reminder, volume of a cylinder is big B times H. So big B is going to be pi radius squared. Bear, stop. Bear, cut it out. 3.4 squared gets me 11.56 times 8.6 gets me this really big number. So the volume is going to equal 99.416 pi. Okay, that's how much it can hold. Now the water is being pumped out at a rate of 36 cubic feet per minute. Okay, so if I can pump out 36 feet of water in 1 minute, how long will it take me to pump out 99.416 pi of water. So we are going to do in parentheses, we've got 99.416 pi, close the parentheses, divided by 36. And you get to the nearest minute, it'll take approximately 9 minutes to empty our water tank. All right, that is cones, and then a reminder about cylinders. That's all I have for you. If you have any questions for me, or if you have any questions at all, please see your teacher during their normally scheduled tutorial times, and I will see you in the next video. Bye!
Ow!